What's up everyone, welcome to our next video. And if you have no idea as to what sort of a reaction is this, well then you are exactly in the right place, because today we're going to find that out. Stay tuned for the lecture. Today we're going to talk about 5 different types of chemical reactions, and to start it off we have combination reaction. Well, combination reactions are pretty simple. Here we have multiple number of reactants that combine together to give one or multiple products. And one of the simplest of examples of combination reaction is carbon reacts with oxygen to give carbon dioxide. We have here the carbon which reacts with oxygen to give carbon dioxide. This is the simplest example of combination reaction. We have 2 reactants combining together to give one product. That is a combination reaction. From the name itself, you can understand what sort of a reaction this is. Okay, so this is one of the simplest examples. There are multiple other examples. Another example that we have is calcium oxide reacts with water, give calcium hydroxide, CaOH twice. This is another example of combination reaction. We have calcium oxide as one component, water as the second component, which combine together to form one product, which is calcium hydroxide. Well, if you are thinking of multiple products, then we have another very common example, that is our reaction in photosynthesis. We have 6CO2 plus 12H2O. I am writing a balanced equation here. Gives C6H12O6 plus 6O2 plus 6H2O. This is an example of combination reaction where we have multiple reactants as well as multiple products. Here carbon dioxide and water react together in the presence of obviously sunlight and chlorophyll. They react together, they combine together to form 3 different products. So this is also an example of combination reaction. From our previous video, I hope you are clear with the balancing of chemical reactions, and if you are not clear why it is 6, 12, 6, 6, then please go ahead to our previous video, watch that lecture so that you can understand why these numberings are given, what is the meaning. So if you go out there, you will be easily able to understand this lecture. Okay, so these are the examples of combination reaction. We have given 3 different examples. Very simple, another simple one. This one is a very common, but it is different because here we have multiple products. Okay, so I hope it's clear. This is called combination reaction. We will combine the reactants to give out products. Okay, then we move on to the second type of reaction, that is the decomposition reaction. So if we look into that, we will have decomposition. Decomposition means breaking down. So we have decomposition reaction. Here we will have one single reactant which is breaking down to give multiple products. Okay, one of the very easy examples is water breaking down to give hydrogen ion and the hydroxide ion in electrolysis. We have water. If we put electricity here, the presence of electricity, water breaks down to give hydrogen ion and one hydroxide ion. Okay, so this is one example of decomposition reaction, one component giving out multiple products, and here the products are in ionic form. Okay, so we have this as an example of decomposition reaction. I'll be giving 2 more examples, and these 2 examples will be different, and we will see how they are different. Okay, let us look at another example where we have ferrous sulfate, FeSO4. This ferrous sulfate, when we apply heat to this, heat as a source of energy, then it breaks down. It breaks down to give ferric oxide, Fe2O3, plus we have sulfur dioxide and sulfur trioxide. So this is another decomposition reaction. Here we have taken one reactant which is ferrous sulfate, and we are providing heat so that it breaks down to give Fe2O3, which is ferric oxide, sulfur dioxide and sulfur trioxide. Now if you are thinking why this is ferrous and why this is ferric, well, you need to know the valencies. In this case, ferrous is having a valency of +2 and hence the name is ferrous. Here it is a valency of 3 +3 and that's why its name is ferric. So this is ferrous sulfate, this is ferric oxide, and sulfur dioxide, sulfur trioxide. So three different components formed from a single component when heat is applied. So heat is one source of energy that you are providing. Another example of another type is, suppose you have AgCl, silver chloride. If in the presence of sunlight, that is light energy, in the presence of sunlight, this thing breaks down to give silver and chlorine gas. Okay. So this is another type of decomposition, one reactant and multiple products, two products here, but here the source of energy is different, it is sunlight. Okay, so in case of different types of energy sources, we may have decomposition reaction. Now it is really important to understand that for decomposition reaction to take place, we must have some source of energy until and unless the reaction is spontaneous. Now, spontaneous and non-spontaneous reactions, they are different. So try to understand, because it is not given in your book or anything. So just to understand that why we need energy. These reactions are not spontaneous reactions, and by spontaneous reactions, I mean the reactions which don't require energy. They by themselves at normal temperature, they will break down to give simpler components. Non-spontaneous reactions are those reactions which require energy, means they are stable at normal temperature. Like this water is stable at normal temperature. If you give electricity, if you pass electricity through it, it will break down into water, hydrogen ion and hydroxide ion. Ferrous sulfate is also normal, or ferrous sulfate is stable at a normal temperature, but if you provide heat, then it breaks down to ferric oxide, sulfur dioxide, sulfur trioxide. Okay, same case for AgCl. So these are non-spontaneous reactions, and as a result of that, we need some energy in order to break them down into simpler components. So this is about decomposition reaction. So I hope you understand. You can say this is the somewhat opposite of combination reaction, because in combination reaction we had reactants combining to give one product. In this case, we have the product, means we have the reactant, one reactant, and that will be breaking down into multiple components. Okay, so decomposition reaction means breaking down, combination means combining. From the name itself, both are clearly understandable. Let us move into the next phase of our next type of reaction, which is the displacement reaction. Let's move on to that. So in case of displacement reaction, we will have one atom of an element which will be displacing another atom of an element. Okay, so let's see what I mean. Let us take ferrous, which is iron, and let us put it in a solution of copper sulfate. So ferrous will be our solid, copper sulfate will be an aqueous, means it is in a solution of water. So what will be the reaction? The reaction goes on like, the solution becomes ferrous sulfate, FeSO4, this one becomes the solution. The copper comes out and becomes the solid. So what happens here, if you take a solution of copper sulfate and you add ferrous to it, after some time what is observed is ferrous sulfate becomes a solution and the copper comes out into the solution and sediments at the bottom. Now why does this take place? Well, see, here ferrous has more reactivity compared to copper, and that's why ferrous is able to displace copper and take its place here. So ferrous is displacing copper, copper is going out and becoming alone, and ferrous is taking the place of copper to become ferrous sulfate. I like to explain this with a very common example. Suppose a couple. So let's take AB as a couple. So A is the boy and B is the girl. Okay. So AB is a couple. So A decides one day that he wants to introduce his friend to his girlfriend. So we have C, who is the friend of A. So this is a boy, a girl, and another boy. What we see after some time, B has moved on with C and A has become lonely. It's alone. Now why does this happen? This is because C is more attracted towards B, or B is more attracted towards C. They have a more reactivity. C must have higher reactivity in order to stay with B and to remove A. Now by higher reactivity, I mean more attraction. B must be more attracted towards C in order to remove A from the zone. So we have AB as a couple. C is the external source that comes in. Because of higher reactivity between B and C, well, B and C come together and A is moved out. That's exactly what happens here. Here, ferrous is the C, is the outcoming person, the person who comes from the outside. And copper and sulfate are the couple. So copper and sulfate have a good understanding between them, but ferrous just comes in from outside, and because of the more charming nature of ferrous decides to displace copper, and sulfate, who is just blown away by the charm of ferrous, sulfate moves in with copper to give, sulfate moves in with ferrous to give ferrous sulfate, and copper, because of his less charm, is kicked out. That's how displacement reaction takes place. Displacement reaction is all based on the reactivity. Now, how to understand which element has higher reactivity? For that, you can go to page number 45 of your NCERT book. In that page, you will find one green box at the bottom, which is given activity series of elements. So there you can find which element is more reactive, which element is less reactive. Let us take this case into here. If I take copper and try to react it with ferrous sulfate, what will happen? Well, in this case, no reaction will take place, no product will be formed. Why? Because copper is not more reactive than ferrous. Ferrous is already more reactive than copper. So ferrous has displaced copper because ferrous had higher power. But here, copper is not having that higher power. Ferrous has already that higher power. So copper cannot displace ferrous. So hence, no reaction. So if the compound that is coming in as a separate particle or separate individual, if I want to say, and that has higher reactivity compared to the one in the compound. Here copper is present in the compound. If ferrous has higher reactivity than copper, then ferrous will be able to displace. So in case of AB plus C, if C has higher reactivity, then only it can displace A. Then only C will displace A will be kicked out. Otherwise, if C has less reactivity, then A cannot be displaced and B will not be attracted to C. So that is what we call a displacement reaction. I hope that is clear. So if you have any other reaction and you are asked what will be the product, first remember or first check whether this element here is having higher reactivity. If it is having higher reactivity, then there will be displacement. If not, then there will be no displacement. Okay. Now let's move on to the next version of displacement, which is double displacement reaction. Okay, so remember the reaction I showed you at the beginning of the of our lecture. Well, I'm going to take that example and show it to you now. So here we have double displacement reaction. Double displacement. So in two places we are going to see displacement. Let us check that reaction out. Okay. So we have sodium sulfate, Na2SO4, sodium sulfate, plus we will take barium chloride, BaCl2. When this reaction takes place, it forms sodium chloride, NaCl, which is twice, and we have barium sulfate. Okay, what happens here? Here we have sodium bonded to sulfate and barium bonded to chloride. After the reaction, sodium and chlorine get together and barium and sulfur or sulfate get together and form different compounds. Now, what is the reason for these sort of reactions? Two elements from two different compounds combining and the remaining two are combining by themselves. Now, why this happens? Why is there an exchange? Now, the reaction is very simple. Actually, two factors play a role here. First is the reactivity, obviously. Sodium is more reactive than barium. So, sodium will try to react. But why will sodium try to react with chlorine? It is already with sulfate. Why should it try to react with chlorine? Since sodium is more reactive, so it will have the higher authority. Okay, just so as to say, it will have higher authority over barium. Now, sodium has a valency of +1. Chlorine has a valency of -1. If you look at the valency of sulfate, it has -2 and barium has a valency of +2. Okay. So from here you can understand why barium and sulfate are trying to be together and sodium and chlorine are trying to be together. This is because of higher affinity. Sodium has more liking for chlorine and barium has more liking for sulfate. And as a result of that, since sodium is more reactive, it will first give the push to react with chlorine and hence it moves in with chlorine. Then barium will be left, but barium also has higher affinity towards sulfate. So barium will be now able to bond with sulfate. Okay. So sodium, because it is highly reactive, plus it has more affinity towards chlorine. So it will try to go and displace barium. So it will remove barium, it will take chlorine's, it will take this position with chlorine, and it will move out as sodium chloride. Okay, since he has more power. Now barium, which is left with no one, realizes that it has sulfate to bond with, and sulfate and barium have higher affinity because they are both of their valences are same 2. So barium will now try to move in with sulfate, and since they have higher affinity or higher liking, they become a single compound. So this is an example of double displacement reaction. In case of displacement reaction, the higher reactive metal displaced the lower reactive metal. In this case, we have exchange of ions taking place. Here, ions exchange between themselves. Sodium is going in place of barium, barium is coming in place of sodium. So they are coming together, and these two are coming together in order to form different products. Okay, so I hope it is clear. 4 reactions we have studied till now. The combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. So this is the reaction that I gave at the beginning of the lecture. Now I hope it is clear. This is because of higher affinity and reactivity combined together to give this reaction of double displacement, where exchange of elements or exchange of ions take place. Okay, now let us move into the last part, which is the oxidation and reduction reaction. Very simple, oxidation and reduction, you must know, I guess. Oxidation means, from the name itself, it says that it needs oxygen. So any compound, when it gains oxygen, will be oxidized, and any compound which loses oxygen will be reduced. So move into oxidation and reduction. Okay, let us take any example where oxygen is added to a compound. So like our first reaction that we took, carbon plus oxygen gives carbon dioxide. So here oxygen is added to carbon. So what has happened to carbon? Carbon has received oxygen to give carbon dioxide. So carbon has become oxidized. Okay, carbon has become oxidized. Okay, I hope that is clear. Now let us move on to see a reduction reaction. Reduction reaction, by the definition we have learned till now, is losing of oxygen. Oxygen must be lost from a compound in order to get a reduction reaction. So let's look at one of the examples of those. Okay. So copper oxide, when reacts with hydrogen, heat is supplied, then they combine together to form copper and water. A simple reaction. Copper oxide reacts with hydrogen, copper loses the oxygen and it forms water, and copper comes out as stone. So what happens to copper here? Copper here has lost the oxygen, so it must be reduced. So the reaction taking place in this reaction is reduction reaction. Okay, this is an oxidation reaction and this is a reduction reaction. So I hope that is clear. Okay. Now, oxidation and reduction can be explained in another way, where we have gain of hydrogen or loss of hydrogen. So in terms of hydrogen also we can explain. If it is gain of hydrogen is called reduction, and loss of hydrogen is called oxidation. Exactly the opposite of oxygen. Oxygen gained is oxidation, oxygen lost is reduction. Hydrogen gained is reduction, and hydrogen lost is oxidation. So it is exactly the opposite of each other. Okay, so I can write it down. If you want, you can note it down too. Gain of oxygen is called oxidation, and loss of oxygen is called reduction. This oxidation is same as loss of hydrogen, and reduction is same as gain of hydrogen. So this is the basic funda or basic law between oxidation and reduction. Okay, so gain of oxygen or loss of hydrogen is oxidation, and loss of oxygen or gain of hydrogen is reduction. So let us see some reactions regarding this case, loss and gain of hydrogen. Let us take this reaction where we have H2 reacting with O2 to give H2O. Okay. So what happens here? Look at oxygen. Oxygen was alone earlier. After the reaction, oxygen has gained some hydrogen. So what happens to oxygen here? Oxygen is reduced. Okay. Oxygen here has been reduced because oxygen has gained hydrogen in the product. If I write the reverse of this reaction, where we have twice H2O giving twice H2 plus O2, then what do we have here? This compound water, and if we look at where it goes to oxygen, in the reverse reaction of this, if I am trying to break down water into hydrogen and oxygen, what happens here? We have twice H2 and O2, and here we had H2O. So let's look at oxygen. What happens to oxygen? Here it was with hydrogen. After the reaction, it has lost the hydrogen. So oxygen has lost hydrogen. So losing of hydrogen means oxidation reaction. These are the examples of reactions where hydrogen is lost or gained. Okay. Now, reaction in which both this oxidation and reduction take place, a same reaction in which both these reactions take place, is called a redox reaction. So let us see one example of redox reaction. I am going to take the same example as I took earlier. Copper oxide plus hydrogen gives copper plus water. Let's look into this. In case of copper oxide, after the reaction, copper becomes alone. So what happens to copper? Copper had oxygen, it lost the oxygen in the product. So losing of oxygen means reduction. Here reduction has taken place. In case of hydrogen, hydrogen was alone, but after the reaction, hydrogen has gained what? Oxygen. So what happens to hydrogen? Since it has gained oxygen, it is oxidation. So in this reaction itself, we have two parts. One part is undergoing reduction, the other part is undergoing oxidation. As a result, these sort of reactions are called redox reactions. A reaction in which both oxidation and reduction take place simultaneously is called a redox reaction. So this is all about the types of reactions that we have in this chapter. I hope it was easy because some things look tough. Chemical reactions sometimes look very tough, but they are not. So if you go through whatever I have said, if you have any problem, then rewind the video, because if you missed anything, then you may have some problem. So go through whatever I have said in the video. It will be easy for you. So I hope you understood. I hope you enjoyed. So until next time.